into a moment of calm. Find a cozy spot, grab a pillow, and let your body sink into relaxation. Close your eyes if you like, or simply let your breath slow. This tutorial is designed to flow like a gentle stream, guiding you through the world of JavaScript with ease. As we begin, remember to like and subscribe for more relaxing coding journeys. Let the rhythm of this lesson carry you forward. Good morning, everyone, and welcome to this session on JavaScript programming. Today, we'll start by introducing JavaScript and its pivotal role in modern web development. We'll dive into its core concepts and features, exploring how it enables dynamic and interactive web experiences. Next, we'll take a look at the evolution of web technologies, tracing how JavaScript has grown from a simple scripting language to a powerful tool for both front-end and back-end development. Finally, we'll highlight practical applications and use cases, showing how JavaScript is used in real-world scenarios like building responsive websites, mobile apps, and even server-side applications. By the end of this session, you'll have a solid understanding of why JavaScript is an essential skill for any web developer. JavaScript is a high-level, interpreted programming language that is primarily used for client-side web development. Unlike compiled languages, JavaScript runs directly in the browser, allowing developers to create dynamic content without needing to reload the page. This makes it ideal for tasks like form validation, animations, and real-time updates. One of the key strengths of JavaScript is its ability to manipulate the document object model, which is the structure of a web page. This means you can change text, images, and even entire sections of a web page on the fly. JavaScript works across all modern browsers, ensuring consistency and accessibility for users regardless of their device or platform. Its versatility and ease of integration with HTML and CSS make it a fundamental tool for any web developer. In web development, JavaScript plays a crucial role in both front-end and back-end scenarios. On the front end, it enhances user experience by enabling interactive elements such as drop-down menus, autocomplete features, and dynamic content loading. This makes websites more engaging and user-friendly. On the back end, JavaScript has evolved significantly with the introduction of Node.js, which allows developers to use JavaScript for server-side scripting. This means you can build full-stack applications using a single language, streamlining the development process. Frameworks like React and Express further expand JavaScript's capabilities, making it possible to create complex, scalable applications. Whether you're working on a simple website or a large-scale enterprise application, JavaScript integrates seamlessly with HTML and CSS to create interactive and responsive web pages. One of the defining features of JavaScript is its dynamic typing, which means variables can hold values of any type without needing explicit declarations. This flexibility allows for faster development, but requires careful handling to avoid errors. JavaScript also follows an event-driven and asynchronous programming model, which is essential for handling user interactions and non-blocking operations like API calls. This model ensures that the browser remains responsive even when performing complex tasks. Additionally, JavaScript is cross-platform, meaning it can run on browsers, servers, and even mobile devices through frameworks like React Native. The language's rich ecosystem includes a vast array of libraries and frameworks, such as React for building user interfaces, Vue for progressive web applications, and Angular for enterprise-level solutions. These tools empower developers to create efficient and scalable applications with minimal effort. JavaScript was created in 1995 by Brendan Eich while working at Netscape. Initially named Mocha and later renamed JavaScript to capitalize on the popularity of Java. Despite its name, it is a distinct language with its own syntax and features. In 1997, it was standardized as ECMAScript, a specification that ensures consistency across different browsers and environments. The release of ECMAScript 6, or E6, in 2015 marked a major milestone, introducing modern syntax features like arrow functions, classes, and modules that made code more readable and maintainable. Since then, JavaScript has continued to evolve with new standards and community contributions, adding features like async await for handling asynchronous operations and improving performance. This ongoing evolution ensures that JavaScript remains a relevant and powerful tool for developers in an ever-changing technological landscape. To summarize, JavaScript is an essential tool for modern web development, offering both simplicity and powerful capabilities for creating dynamic applications. Its ability to run on the client side, server side, and across multiple platforms makes it a versatile choice for developers. Understanding its role and features provides a strong foundation for learning more advanced concepts and frameworks. As we move forward, we'll explore practical examples and hands-on coding exercises to apply what we've learned. By the end of this course, you'll be equipped with the skills to build interactive websites, mobile apps, and even server-side applications. Let's get started with some real-world examples and see how JavaScript brings web development to life. A development environment for JavaScript is the collection of tools, configurations, and settings that allow you to write, test, and run JavaScript code efficiently. Think of it as your workspace where you can create, debug, and manage your projects. Proper setup is crucial because it streamlines your workflow, reduces errors, and ensures consistency across different systems. The key components include a code editor, Node.js for server-side execution, version control tools like Git, and project management utilities. By investing time in setting up your environment correctly, you save hours of frustration later. This presentation will guide you through each step to build a robust foundation for JavaScript development. Choosing a code editor is the first step in building your development environment. Popular options include Visual Studio Code, which is lightweight and highly customizable, and Sublime Text, known for its speed. Download the editor of your choice from its official website. Then follow the installation instructions. Once installed, enhance your experience by installing essential extensions. For JavaScript, the JavaScript extension provides syntax highlighting and IntelliSense. EaseLint helps maintain code quality by detecting errors, and Live Server allows you to preview your web projects in real time. These tools transform a basic code editor into a powerful workspace tailored for JavaScript development. Node.js is a runtime environment that allows you to execute JavaScript outside of a web browser, making it essential for server-side development and build tools. Visit the official Node.js website to download the latest stable version. The installation process includes Node.js and NPM, the package manager for JavaScript. After installation, open your terminal or command prompt and type node v to check the Node.js version and npm v to verify npm. These commands confirm that the installation was successful. Node.js and npm are the backbone of modern JavaScript projects, enabling you to manage dependencies and run scripts seamlessly. Setting up a project begins with organizing your files. Create a dedicated folder for your project, then initialize it with npm init to generate a package JSON file automatically. This file tracks your project's dependencies and scripts. Next, install any required packages using npm install, such as libraries or tools specific to your project. For example, if you're building a web application, you might install Express or React. This structured approach ensures your project remains manageable as it grows, and it allows others to understand and contribute to your work more easily. Version control is a critical skill for any developer, and Git is the most widely used tool for this purpose. Download Git from the official website and follow the installation steps. Once installed, configure your global username and email with git config global username and git config global user email to identify your commits. Finally, initialize a Git repository in your project folder using git init. This creates a history of changes, allowing you to track modifications, revert to previous versions, and collaborate with others effectively. Git is indispensable for managing code changes over time. A well-organized folder structure improves collaboration and maintainability. Place your source code in a src/directory to keep it separate from other files. Use public for static assets like images or CSS that are directly accessible by users. The node modules/folder, generated automatically by npm, contains all your project's dependencies and should never be manually edited. Include a README MD file to document your project's purpose and set up instructions, and a gitignore file to exclude unnecessary files from version control. These practices ensure your project remains clean and easy to navigate. Testing your environment is a simple but vital step to confirm everything works as expected. Create a file named test.js in your project folder and write a basic script like console log hello world. Run the file using the command node test.js in your terminal. If everything is set up correctly, the message hello world will appear. This step also helps identify issues early, such as incorrect Node.js installation or missing dependencies. Pay attention to any error messages, as they provide clues for troubleshooting. A working environment is the foundation for building more complex applications. JavaScript development relies on a variety of tools and libraries to streamline tasks. Linters like EaseLint enforce coding standards and catch potential bugs before they become issues. Bundlers such as Webpack or Vite manage assets, optimize code, and handle dependencies for web projects. Package managers like NPM or Yarn simplify the process of installing, updating, and managing third-party libraries. Familiarizing yourself with these tools enhances productivity and ensures your projects are scalable and maintainable. Each tool serves a specific purpose, and combining them creates a powerful development workflow. When issues arise, systematic troubleshooting is key. Start by checking for typos in commands, as even a single mistake can cause failures. Ensure your Node, JS, and NPM versions are compatible with the tools you're using, as outdated versions may lead to unexpected behavior. If an error persists, search for solutions on platforms like Stack Overflow or GitHub, where developers share their experiences. Remember, no one knows everything, and seeking help is a normal part of the learning process. Documenting your issues and solutions also helps others facing similar challenges. To summarize, we've covered setting up a code editor, installing Node, JS, and NPM, organizing project folders, using Git for version control, and testing your environment. Consistency and organization are the pillars of efficient development, so always strive to follow best practices. The final step is to apply what you've learned by working on small projects. Whether it's a to-do list application or a simple website, hands-on practice reinforces your understanding and builds confidence. Keep experimenting, stay curious, and remember that every expert was once a beginner. JavaScript is a high-level, interpreted programming language that is widely used for building interactive web experiences. It runs in web browsers, allowing developers to create dynamic content that responds to user actions. Beyond the browser, JavaScript also supports server-side development through environments like Node, JS, making it a versatile tool for full-stack applications. The syntax rules of JavaScript are essential because they define how code is structured and interpreted by the browser or runtime environment. These rules include everything from how variables are declared to how functions are defined. key components of JavaScript syntax include variables, which store data types, which categorize the kind of data being stored, operators, which perform operations on values, control structures, which dictate the flow of execution, and functions, which group code into reusable blocks. Understanding these elements is the foundation for writing effective JavaScript code. When working with JavaScript, you can declare variables using the keywords let, const, or var. Each of these keywords has distinct behaviors. Let is block scoped and allows reassignment, making it ideal for variables that may change. Const is also block scoped, but prevents reassignment, which is useful for values that should remain constant. Var is function scoped and has a more traditional behavior, though it is generally less preferred in modern code due to its broader scope. JavaScript supports a variety of data types, including numbers, which can be integers or floating point values, strings, which are sequences of characters, booleans, which represent true or false, null, which signifies the absence of a value, undefined, which indicates a variable has not been assigned a value, objects, which are collections of key-value pairs, and arrays, which store ordered lists of values. For example, the code let age equals 25 declares a variable named age with the numeric value 25, while const name equals Alice assigns a string value to a constant. Variables are crucial because they allow you to store and manipulate data throughout your program, making code more efficient and readable. JavaScript includes a range of operators that perform specific actions on values. Arithmetic operators like addition, subtraction, multiplication, division, and modulus allow you to perform mathematical calculations. For instance, 5 plus 3 equals 8, while 10 minus 4 equals 6. Assignment operators, such as equals, plus equals, minus equals, and multiply equals, are used to assign values to variables. For example, x equals 5 assigns the value 5 to x, while x plus equals 3 adds 3 to x's current value. Comparison operators like equal to, strictly equal to, not equal to, greater than, and less than help evaluate relationships between values. Logical operators, including and, or, and not, are used to combine or negate conditions. For example, if a condition is true and another is also true, the and operator returns true. Expressions in JavaScript are combinations of values, variables, and operators that produce a result. These expressions are fundamental to writing logic that makes decisions or performs calculations in your code. Control structures in JavaScript determine the flow of execution in a program. Conditional statements like if, and else allow your code to make decisions based on specific conditions. For example, if a variable age is greater than or equal to 18, the code inside the if block will execute, printing adult to the console. Else, if and else provide additional branches for handling multiple scenarios. Loops, such as for, while, and do while, enable repetitive tasks. A for loop might iterate over an array to perform an action on each element, while a while loop continues executing as long as a condition remains true. The do while loop is similar, but ensures the code runs at least once before checking the condition. These control structures are essential for creating dynamic and responsive applications, as they allow your code to handle varying inputs and scenarios. By mastering them, you can build complex logic that adapts to user interactions and data changes. Functions in JavaScript are reusable blocks of code that perform specific tasks. They can be declared using the function keyword or the arrow syntax, which is more concise. For example, the function greetName returns a greeting message by concatenating hello with the provided name. Functions improve code organization by breaking down large programs into manageable pieces, making them easier to read, test, and maintain. They also promote code reuse, as you can call the same function multiple times with different arguments. In addition to basic functions, JavaScript supports higher-order functions, which can accept other functions as parameters or return them as results. This feature is particularly useful in modern programming paradigms like functional programming. By encapsulating logic within functions, you can create modular code that is easier to debug and scale, ultimately leading to more efficient and reliable applications. Writing your first JavaScript code is an exciting step in your programming journey. Start by opening a code editor like Visual Studio Code, which provides features such as syntax highlighting and intelligent code suggestions. Begin with a simple statement like console log hello world, which outputs text to the console. This is a common way to test and debug code. Next, declare variables to store values, such as let age equals 25 or const name Alice. Use basic operators to perform calculations or comparisons, like adding two numbers or checking if a condition is true. Once your code is written, test it in a browser's developer console or a Node.js environment to see the results. Debugging is an essential part of the process, so don't hesitate to use console logs or debugging tools to identify and fix issues. Remember, writing code is an iterative process. Refine and improve your code through practice and experimentation. Each small step you take helps build the skills needed to tackle more complex projects. Today, we have covered the fundamental aspects of JavaScript syntax, including variables, data types, operators, and control structures. You have written your first code snippet using console.log and functions, which are essential tools for any JavaScript developer. Practice is key to mastering these concepts, as it helps reinforce your understanding and improves your problem-solving skills. As you continue learning, consider exploring advanced topics such as data structures like maps and sets, or more complex functions like closures and higher-order functions. These concepts will expand your ability to create sophisticated applications. Keep experimenting, ask questions, and don't be afraid to make mistakes. They are part of the learning process. In our next session, we will dive deeper into advanced data structures and functions, building on the foundation we have established today. Stay curious and keep coding. Variables are like labeled containers that hold data values in JavaScript. They allow you to store and retrieve information as you write code. When you declare a variable, you're essentially reserving a space in your computer's memory to hold a specific value. In JavaScript, you can declare variables using 3 keywords: var, let, or const. Each of these has different behaviors and use cases. For example, var is the oldest way to declare variables, but it has some quirks. Let and const are more modern and provide better control over variable scope. When naming variables, you can use letters, numbers, underscores, and $signs. But you can't start a variable name with a number. It's also a good practice to use meaningful names that describe what the variable holds, like age or pi. The keywords var, let, and const each have distinct characteristics. The var keyword is function scoped, meaning it exists within the function it's declared in, but not outside of it. This can sometimes lead to unexpected behavior if not used carefully. The let keyword, on the other hand, is block scoped, which means it only exists within the block of code it's declared in, such as inside a loop or conditional statement. This makes it more predictable and safer to use. The const keyword is also block scoped, but but it's used for values that shouldn't change after they're assigned. For example, if you declare a constant like pi with the value 3.14, you can't reassign it later. This helps prevent accidental changes to important values in your code. An example of this would be let age equals 25, which stores a number, and const pi equals 3.14, which stores a constant value. JavaScript has two main categories of data types: primitive and reference types. Primitive types are the basic building blocks of the language and include numbers, strings, booleans, null, undefined, and symbols. These types store data directly in the variable. Reference types, on the other hand, are more complex and include objects, arrays, and functions. These types store references to data rather than the data itself. This distinction is important because it affects how variables behave when you assign or modify them. For instance, when you assign a primitive value to a variable, it copies the value. But when you assign a reference type, it copies the reference, meaning changes to one variable can affect others. Understanding these differences helps you manage memory and avoid bugs in your code. Primitive data types are the simplest forms of data in JavaScript. Numbers can be integers like 10 or floating point numbers like 3.14. Strings are sequences of characters enclosed in quotes, such as hello world. Booleans represent true or false values and are often used in conditional statements. Null is a special value that represents the absence of any object or value. Undefined occurs when a variable is declared but hasn't been assigned a value yet. Symbols are unique and immutable values introduced in E6, often used as object keys to ensure uniqueness. Each of these types has specific behaviors and uses. For example, numbers can be used in mathematical operations, strings in text manipulation, and booleans in logical decisions. Knowing how to use these types effectively is essential for writing functional code. Reference data types are more complex and allow you to store and organize multiple values. Objects are collections of key-value pairs, where each key is a string, and the value can be any data type. For example, name John is an object with a key called name. Arrays are ordered lists of values, such as 1, 2, 3, and can hold any type of data. Functions are reusable blocks of code that perform specific tasks, like function add-a, b return a plus b. Unlike primitive types, reference types don't store the actual data in the variable. the data is located in memory. This means that when you assign an object or array to a new variable, both variables point to the same data. Modifying one will affect the other, which is a key concept to understand when working with these types. Variable scope determines where a variable can be accessed in your code. The var keyword is function scoped, meaning it's available throughout the entire function it's declared in, even if it's declared inside a block. This can sometimes lead to unexpected behavior, especially if you're not careful. In contrast, let and const are block scoped, meaning they're only available within the block of code they're declared in, such as inside a loop or conditional statement. This makes them more predictable and easier to manage. Another important concept is hoisting, which is when JavaScript moves variable declarations to the top of their scope during the compilation phase. However, var variables are hoisted, while let and const variables are not. This means that using var can lead to issues if you try to access a variable before it's declared. Modern JavaScript developers typically avoid var and use let and const instead to avoid these pitfalls. In summary, variables are essential for storing and manipulating data in JavaScript. Choosing the right type of variable and data type for your task can make your code more efficient and easier to maintain. Using let and const instead of var helps prevent scope-related issues and makes your code more reliable. Understanding the difference between primitive and reference types is crucial for managing data correctly, especially when working with complex structures like objects and arrays. As you practice declaring variables and experimenting with different data types, you'll gain a deeper understanding of how JavaScript works. This knowledge will help you write cleaner, more efficient code and avoid common mistakes. Keep exploring and experimenting to build your skills. Control flow is the sequence in which a program's code is executed. It determines how instructions are processed, allowing programs to make decisions and perform actions based on specific criteria. Conditional statements are essential tools in control flow, enabling programs to evaluate conditions and choose different paths of execution. These statements include if else, and switch, which help structure logical decisions in code. Understanding control flow is crucial for creating dynamic and responsive applications. Conditional statements are used to execute different blocks of code, depending on whether a condition evaluates to true or false. They allow programs to respond to varying situations, making applications more interactive and adaptable. For example, a program might check user input to determine if it meets certain criteria, validate data to ensure correctness, or branch logic to handle multiple scenarios. These statements are the foundation of decision-making in programming, enabling complex behaviors through simple yes or no questions. The if statement is the most basic conditional structure in JavaScript. It executes a block of code only if a specified condition is true. The syntax starts with the keyword if followed by a condition in parentheses, and the code to run is enclosed in curly braces. For instance, if a person's age is greater than or equal to 18, the program can display a message indicating they are an adult. This allows for targeted execution of code based on specific requirements. The else statement complements the if statement by providing an alternative block of code to execute when the if condition is false. This ensures that every possible outcome is addressed. For example, if a test score is above 50, the program might print pass. But if it is not, the else block would print fail. This dual structure ensures that all scenarios are accounted for, making the logic more robust and complete. The else if statement allows for checking multiple conditions in sequence. It is used when there are several possible outcomes, and the program needs to evaluate each condition in order. For example, a grading system might first check if a student's marks are 90 or higher, then check if they are 60 or higher if the first condition is not met. This creates a chain of conditions, making the code more organized and easier to read. The switch statement is another way to handle multiple conditions by evaluating an expression and matching it to a specific case. It is particularly useful when there are many possible values to check. The syntax starts with the keyword switch, followed by an expression in parentheses, and then a series of case blocks. Each case is compared to the expression, and if a match is found, the corresponding code is executed. This structure can simplify complex if-else, if chains. Logical operators are used to combine or modify conditions in JavaScript. The AND operator requires both conditions to be true for the overall condition to be true. The OR operator allows for at least one condition to be true. The NOT operator reverses the Boolean value of a condition. For example, checking if a user is both logged in and has permission might use the AND operator, while checking if a value is either high or low might use the or operator. These operators help create more nuanced and flexible conditions. When using conditional statements, it is important to keep conditions clear and concise to avoid confusion. Deeply nested conditions can make code harder to read and maintain, so it is best to simplify them where possible. Testing edge cases ensures that all possible scenarios are handled correctly. Conditional statements are fundamental to programming logic, enabling applications to adapt and respond to a wide range of situations. Mastering them is essential for writing efficient and effective code. Functions are reusable blocks of code that perform specific tasks. Think of them as little machines that take in inputs, process them, and produce outputs. They are the building blocks of JavaScript, allowing developers to break down complex problems into smaller, manageable pieces. By using functions, we can avoid writing the same code multiple times, which makes our programs more efficient and easier to maintain. Functions also help in organizing code logically, so that each part has a clear purpose. For example, a function might handle user input, another might process data, and a third might update the user interface. This modular approach not only improves readability, but also makes debugging and testing much simpler. Additionally, functions can accept parameters, which are like placeholders for values that we pass into the function. They can also return values, which means they can send data back to the part of the code that called them. This makes functions incredibly versatile. In JavaScript, functions are considered first-class citizens, which means they can be treated like any other data type. They can be assigned to variables, passed as arguments to other functions, and even returned from functions. This feature opens up powerful programming techniques, such as higher-order functions and functional programming patterns. To define a function in JavaScript, we use the function keyword followed by the function name and a set of parentheses. Inside the parentheses, we can list parameters, which are the inputs the function expects. The code that the function executes is enclosed in curly braces. For example, a function called myFunction would look like this: function myFunction. However, there are other ways to define functions. One common approach is using function expressions, where the function is assigned to a variable. This allows for more flexibility, as the function can be stored in variables, arrays, or even passed around as arguments. Another modern method is arrow functions, which use the equal syntax. Arrow functions are particularly useful for writing concise code and automatically bind this keyword to the surrounding context, which can be helpful in certain scenarios. It's important to note that functions can be named or anonymous. Named functions have a specific name that can be used to reference them, while anonymous functions do not have a name and are often used as arguments to other functions or in expressions. This versatility in defining functions is one of the reasons JavaScript is so powerful and widely used. Function parameters are the variables that a function uses to receive data from the caller. When we define a function, we specify these parameters inside the parentheses, and they act as placeholders for the actual values that will be passed in when the function is called. For instance, if we have a function called greet, it might take a parameter called name, like this: function greetName. This allows the function to use the name variable inside its body. JavaScript also supports default parameters, which provide a fallback value if no argument is passed. For example, if we set a default value of guest for the name parameter, the function will use that if no name is provided. This can make functions more robust and user-friendly. Another powerful feature is the use of REST parameters, which allow a function to accept an indefinite number of arguments. By using the three-dot syntax, we can collect all the arguments into an array. For example, a function called sum could take multiple numbers and add them together using a REST parameter. This makes functions more flexible, as they can handle varying numbers of inputs without requiring the caller to pass them in a specific format. Return values are the results that a function sends back to the part of the code that called it. The return statement is used to specify what the function should output. When a function reaches a return statement, it immediately stops executing and sends the specified value back to the caller. For example, a function that adds two numbers might return the sum using return a plus b. If a function does not have a return statement, it will automatically return undefined, which is the default value for functions that do not explicitly return anything. This means that functions can be used to compute values and then use those values in other parts of the program. For instance, the return value of one function can be passed as an argument to another function, creating a chain of operations. This makes functions a crucial part of JavaScript programming, as they allow for the creation of complex workflows by combining simple, reusable pieces of code. Additionally, return values can be stored in variables, used in conditional statements, or even returned from nested functions, making them highly versatile in different programming scenarios. Understanding function scope is essential for writing clean and bug-free JavaScript code. Scope refers to the context in which variables and functions are accessible. In JavaScript, functions create their own scope, which means that variables declared inside a function are not accessible outside of it. This helps prevent unintended modifications to variables and reduces the risk of naming conflicts. For example, if a variable is declared inside a function, it cannot be accessed from outside that function, even if it has the same name as a variable in the outer scope. This is known as function scope. However, JavaScript also has global scope, which is the outermost scope where variables and functions declared outside of any function are accessible throughout the entire program. While global scope can be useful for variables that need to be accessed from multiple parts of the code, it can also lead to issues if not managed carefully. By limiting the use of global variables and relying on function scope, developers can create more modular and maintainable code. This practice helps ensure that variables and functions are only accessible where they are needed, improving code organization and reducing the likelihood of errors. Variable scope in JavaScript is determined by how and where variables are declared. The var keyword, which is an older way of declaring variables, has function scope, meaning that variables declared with var are accessible throughout the entire function in which they are defined. This can sometimes lead to unexpected behavior, especially if variables are accidentally modified in different parts of the code. In contrast, the let and const keywords introduced in E6 have block scope, which means that variables declared with these keywords are only accessible within the block of code in which they are defined. A block is typically defined by curly braces, such as in loops, conditionals, or even standalone code sections. For example, if a variable is declared with let inside a function, it is only accessible within that function's scope. This level of control allows developers to write more precise and predictable code. Additionally, nested functions can access variables from their outer scope, which is a powerful feature for creating closures and encapsulating data. By understanding the differences between var, let, and const, developers can make informed decisions about how to structure their code for clarity and reliability. Closures are one of the most powerful features of JavaScript, allowing functions to retain access to their outer scope even after the outer function has finished executing. A closure is created when a function is defined inside another function and has access to the outer function's variables. This means that the inner function can remember the environment in which it was created, even if the outer function has already completed. For example, if an outer function declares a variable and an inner function uses that variable, the inner function can still access the variable even after the outer function has returned. This is particularly useful for creating private variables and functions that are not directly accessible from outside the scope. Closures are widely used in JavaScript for data encapsulation, where certain variables are kept private and only accessible through specific functions. They also play a crucial role in patterns like modules, where functions and variables are grouped together and exposed through a public interface. Additionally, closures are essential for implementing callbacks and asynchronous programming, as they allow functions to carry their environment with them, ensuring that the correct data is available when needed. Hoisting is a behavior in JavaScript where variable and function declarations are moved to the top of their scope during the compilation phase. This means that functions declared using the function keyword can be called before they are defined in the code. For example, if a function is declared after it is called, the code will still work because the function is hoisted to the top of its scope. However, this is not the case for function expressions, which are assigned to variables. In such cases, only the variable declaration is hoisted, not the function itself. This means that trying to call a function expression before it is assigned will result in an error. For instance, if a function is assigned to a const variable, the code will throw an error if it is called before the assignment. Understanding hoisting is important for writing predictable and error-free code, as it can lead to unexpected behavior if not properly accounted for. Developers should be cautious about the order in which functions and variables are declared, especially when working with function expressions and variables declared with let or const, which are not hoisted in the same way as var, immediately invoked functions function expressions, or IIFEs, are functions that are executed as soon as they are defined. The syntax for an IIFE involves wrapping the function in parentheses and then immediately calling it with a set of parentheses. This pattern is often used to create a private scope, preventing variables and functions from polluting the global namespace. For example, an IIFE might look like function, or using arrow functions equals. By executing the function immediately, IIFEs are useful for initializing code that should run once and not be accessible elsewhere in the program. This is particularly helpful in module patterns, where functions and variables are encapsulated within the IIFE, and only specific parts are exposed. IIFEs are also commonly used to avoid naming conflicts, especially in large applications where many functions and variables might otherwise be in the global scope. This technique ensures that the code inside the IIFE is isolated and does not interfere with other parts of the program, making it a valuable tool for creating clean and maintainable JavaScript code. Functions are the foundation of JavaScript programming, enabling code reusability, modularity, and structured development. By breaking down programs into functions, developers can create more maintainable and scalable code. Understanding scope and closures allows for better control over variable access and data encapsulation, reducing the risk of unintended side effects. The ability to return values and pass functions as arguments opens up a wide range of possibilities for building complex applications. JavaScript's support for multiple function definitions, such as function expressions and arrow functions, provides flexibility in writing concise and readable code. Additionally, features like hoisting and IIFEs help manage the execution order and scope of functions, ensuring that code behaves as expected. As developers continue to explore JavaScript's capabilities, mastering functions and their associated concepts becomes essential for creating efficient, reliable, and high-quality applications. Whether working on small scripts or large-scale projects, the principles of functions and scope remain critical for effective programming. By leveraging these tools, developers can build robust solutions that are easy to understand, test, and extend over time. Strings represent text data in JavaScript, allowing developers to work with sequences of characters. These are essential for storing and manipulating textual information, such as names, addresses, or any form of written content. Numbers, on the other hand, include integers, floating point numbers, and special values like none, which stands for not a number. These data types are the building blocks for performing calculations, comparisons, and transformations in code. Together, strings and numbers form the foundation for handling dynamic data in JavaScript, enabling everything from simple variable assignments to complex data processing tasks. String operations in JavaScript include concatenation, which is the process of joining two or more strings together using the plus operator. For example, hello plus world would result in hello world. Another powerful feature is template literals, which use backticks to create multi-line strings and allow for easy interpolation of variables. For instance, hello name dynamically inserts the value of the variable name into the string. Additionally, JavaScript provides a variety of string methods, such as to uppercase, to convert text to uppercase, to lowercase for lowercase, trim to remove white space, split to divide a string into an array, and slice to extract a portion of the string. These tools make string manipulation both flexible and efficient. Strings in JavaScript have properties and methods that allow for deeper interaction. One key property is length, which returns the total number of characters in a string. For example, JavaScript has a length of 10. The charat method retrieves a specific character at a given index, such as JavaScript, char at 0 returning. J, the index of method, helps locate the first occurrence of a substring within a string, while the replace method allows for substituting a part of the string with another value. These properties and methods are invaluable for tasks like searching, modifying, and analyzing text data. Numbers in JavaScript are represented using the number data type, which can handle both integers and floating point values. For example, 42 and 3.14 are both valid numbers. However, JavaScript also includes special values like none, which occurs when an operation fails to produce a valid number, such as dividing a number by a non-numeric string. Another special value is infinity, which represents a value that exceeds the maximum safe number in JavaScript, often resulting from division by 0 or operations that produce extremely large numbers. Understanding these edge cases is crucial for writing robust and error-free code. Arithmetic operations in JavaScript include basic operations such as addition, subtraction, multiplication, division, and modulus. For example, 5 plus 3 equals 8, and 10 minus 2 equals 8. Increment and decrement operators like plus plus and are used to increase or decrease a value by 1. Assignment operators such as plus equals, 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 slash equals, and percent equals allow for shorthand notation when performing operations and assigning results. For instance, x plus equals 5 is equivalent to x equals x plus 5. These operators streamline calculations and improve code readability. JavaScript provides several methods and properties for working with numbers. The toFixed method rounds a number to a specified number of decimal places, such as 314159, to fixed 2 returning 3.14. The toString method converts a number into a string, enabling seamless integration with text-based operations. Additionally, parseInt and parseFloat are used to convert strings into numeric values, with parseInt handling integers and parseFloat accommodating decimal points. These tools are essential for tasks like formatting output, parsing user input, and ensuring data consistency. Type conversion in JavaScript can occur explicitly or implicitly. Explicit conversion involves using functions like number and string to transform data, such as number 123, converting a string to a number, or string 456, turning a number into a string. Implicit conversion happens automatically during operations, like 10 plus 5, resulting in 105, because the number is converted to a string. To check the data type of a value, the typeof operator is used, returning results like string, number, or undefined. Understanding these conversions helps prevent unexpected behavior in code. When working with strings and numbers, there are common pitfalls to avoid. For instance, concatenating large amounts of text using the plus operator can be inefficient. Instead, using array join is more performant. Special values like nN and infinity can cause errors if not handled carefully, so it's important to validate calculations. Additionally, using strict equality equals instead of loose equality equals prevents type coercion issues, ensuring that both the value and data type match. These practices help create more reliable and maintainable JavaScript code. In conclusion, strings and numbers are fundamental to JavaScript programming, enabling the dynamic handling of data in applications. Mastering their properties, methods, and conversion techniques is essential for writing efficient and effective code. By practicing with real-world examples, developers can solidify their understanding and apply these concepts to solve practical problems, whether building simple scripts or complex web applications. A strong grasp of strings and numbers is a cornerstone of successful JavaScript development. Arrays are a fundamental data structure in JavaScript that allow you to store multiple values in a single variable. This makes it easy to manage collections of data, such as a list of names, numbers, or even more complex objects. Each element in an array is assigned an index, starting from 0, which acts as a unique identifier for that position. For example, the first element is at index 0, the second at index 1, and so on. Arrays are incredibly versatile because they can hold a mix of data types, including numbers, strings, objects, and even other arrays. This flexibility makes arrays a powerful tool for organizing and manipulating data in your programs. Creating an array in JavaScript is straightforward. You simply use square brackets to enclose the elements, separated by commas. For instance, the code let fruits equals apple, banana, orange creates an array called fruits containing 3 string values. Accessing elements in an array is done using their index, which is specified in square brackets after the array name. So, fruit 0 would retrieve apple from the array. It's important to note that JavaScript arrays are 0 indexed, meaning the first element is always at position 0. This indexing system is consistent across all array operations and is a key concept to understand when working with arrays. JavaScript provides several built-in methods to manipulate arrays efficiently. The push method adds one or more elements to the end of an array, while pop removes the last element and returns it. The shift method removes the first element of an array, and unshift adds elements to the beginning. These methods allow you to dynamically modify the contents of an array without having to manually restructure it. For example, if you have an array of tasks, push can add a new task to the list, and pop can remove the last task when it's completed. Understanding these methods helps you manage arrays more effectively in your code. The push and pop methods are particularly useful for adding and removing elements from the end of an array. When you call push element, the specified element is appended to the array, and the method returns the new length of the array. For example, if you have an array 1, 2, 3, and use r push 4, the array becomes 1, 2, 3, 4. Conversely, the pop method removes the last element from the array and returns it. So if you call r, pop on 1, 2, 3, 4, the array becomes 1, 2, 3, and the value 4 is returned. These methods are commonly used in scenarios like maintaining a queue or a stack, where elements are added and removed from the same end. The shift and unshift methods operate on the beginning of an array, scenarios where you need to add or remove elements from the start. The shift method removes the first element of an array and returns it, which can be useful for processing elements in the order they were added. For example, if you have an array 1, 2, 3, and call R shift, the array becomes 2, 3, and the value 1 is returned. On the other hand, unshiftment adds one or more elements to the beginning of an array. If you call R unshift 0 on 1, 2, 3, the array becomes 0, 1, 2, 3. These methods are often used in priority queues or when maintaining a list that requires frequent additions at the front. The slice and splice methods offer powerful ways to extract or modify parts of an array. The slice start end method returns a new array containing a portion of the original array, starting at the specified start index and ending before the end index. For example, R slice 1, 3 on 0, 1, 2, 3 would return 1, 2. This method does not alter the original array. In contrast, splice index delete count items modifies the original array by removing or replacing elements. It takes 3 parameters: the index where the modification starts, the number of elements to remove, and optional items to add. For instance, R splice 1, 1, new on 0, 1, 2, 3 would replace the element at index 1 with new, resulting in 0, new, 2, 3. These methods are essential for tasks like slicing data for display or dynamically updating array content. The map method is a powerful tool for transforming arrays by applying a function to each element. It creates a new array with the results of calling the provided function on every element in the original array. For example, if you have an array 1, 2, 3, and use R max equals x2, the result is 2, 4, 6. This method is particularly useful when you need to convert data, such as scaling numbers, converting strings to uppercase, or extracting specific properties from objects. Since map does not modify the original array, it's a great choice for creating new data structures without altering the source. This immutability helps prevent unintended side effects in your code. The filter method allows you to create a new array containing only the elements that pass a specific condition. This is useful for narrowing down data based on criteria, such as selecting numbers greater than a certain value or filtering out invalid entries. For instance, if you have an array 1, 2, 3, 4, and use R, filters equals x2, the result is 3, 4. The function you provide to filter should return a Boolean value where true includes the element and false excludes it. This method is commonly used in scenarios like searching for users with a specific age, filtering products by price, or processing data sets to focus on relevant information. The reduce method is designed to accumulate values into a single result by applying a function to each element of the array. This is particularly useful for tasks like summing numbers, finding the maximum value, or concatenating strings. For example, R reduces sum, x equals sum plus x, 0 on 1, 2, 3 would calculate 6 as the total. The reduce function takes two parameters, an accumulator that holds the accumulated value, and the current element being processed. The initial value, such as 0 in the example, is optional, but helps in cases where the array might be empty. This method is a cornerstone of functional programming in JavaScript and is widely used for aggregating data efficiently. In addition to the methods we've discussed, JavaScript arrays offer several other utilities that are invaluable for common tasks. The for-each method executes a provided function once for each array element, making it ideal for performing actions on each item without creating a new array. The includes method checks whether an array contains a specific element, returning a Boolean value. For example, R includes 2 on 1, 2, 3 would return true. The index of method returns the first index at which a given element appears in the array, or if it is not found. These methods simplify tasks like iterating over data, validating presence, or locating specific elements within an array. Arrays are not only useful for storing and manipulating data, but also for solving practical problems. Sorting an array can be done with the sort method, which rearranges elements in ascending order by default. However, for custom sorting, you can provide a comparator function. For example, our sorta, b equals b minus assorts numbers in descending order. Concatenating arrays is straightforward with concat, which merges two or more arrays into a new one. Additionally, iterating through arrays can be achieved using loops or array methods like map and filter. These techniques are essential for tasks such as organizing data for display, processing user inputs, or analyzing datasets. When working with arrays, following best practices ensures your code remains clean, efficient, and maintainable. One key principle is to avoid modifying an array while iterating over it, as this can lead to unexpected behavior or infinite loops. example, removing elements from an array while using a for loop might skip elements or cause errors. Using const for array declarations prevents accidental reassignment of the array variable, although the elements themselves can still be modified. Prefer immutable methods like map and filter over destructive ones like splice to avoid unintended side effects. These practices help create more predictable and reliable code, especially in larger applications. In summary, arrays are a foundational concept in JavaScript, enabling you to manage collections of data efficiently. Mastering methods like map, filter, and reduce significantly enhances your ability to process and transform data. By practicing these techniques, you can solve real-world problems more effectively, such as analyzing user data, building dynamic interfaces, or optimizing performance. As you continue to explore JavaScript, arrays will remain a critical tool in your programming arsenal, empowering you to create powerful and flexible applications. Events are actions or occurrences that happen in the browser, such as clicks, key presses, or page loads. These events allow users to interact with web pages, and JavaScript provides the tools to respond to them dynamically. By leveraging event handling, developers can create web applications that react in real time, making the user experience more engaging and responsive. For example, when a user clicks a button, JavaScript can trigger a function to update the page or perform a calculation. This interactivity is a cornerstone of modern web development, enabling everything from form validation to complex animations. Understanding events is essential for building applications that feel intuitive and functional. To attach functions to events, JavaScript provides the add event listener method. This function takes two main parameters: the type of event you want to listen for, and the function that should execute when the event occurs. For instance, if you have a button element, you can use the add event listener method to respond to a click event by defining a function that runs when the button is pressed. This approach keeps your code organized and separates the logic of what happens when an event occurs from the HTML structure. The syntax is straightforward, and using this method allows for multiple handlers to be attached to the same event, making your code more flexible and scalable. There are several common types of events that developers work with, each serving a specific purpose. Mouse events include actions like clicking, hovering over an element, or moving the cursor away from it. Keyboard events track when keys are pressed or released, which is useful for capturing user input in text fields or game controls. Form events, such as submitting a form or changing a selection, help manage user interactions with input elements. Window events, like loading a page or resizing the browser window, allow developers to respond to changes in the environment. By understanding these event types, you can create more dynamic and user-friendly interfaces that react to a wide range of user actions. Capturing user input is a critical part of event handling, and JavaScript provides several ways to access this data. The event target property allows you to identify which element triggered the event, making it easier to manipulate specific parts of the page. The event value property can retrieve the current value of an input field, which is useful for validating data before submission. For example, when a user types into a text box, an event listener can check if the input meets certain criteria and provide feedback. Using these properties, you can create more interactive forms and ensure that user data is handled correctly. Additionally, the prevent default method can stop the browser from performing its default action, such as submitting a form without validation. Event propagation refers to the way events travel through the DOM tree, starting from the element that triggered the event and moving up to its ancestors. This process has 3 phases: capturing, targeting, and bubbling. Bubbling is the most commonly used phase, where the event starts at the target element and then moves up to parent elements. However, you can control this behavior using the stop propagation method, which prevents the event from continuing beyond the current element. The current target property is particularly useful for identifying the element that is currently handling the event, even if the event is bubbling up from a child element. Understanding propagation helps you manage complex interactions and avoid unintended side effects. Event delegation is a powerful technique that involves attaching a single event listener to a parent element rather than multiple listeners to individual child elements. This approach is especially useful for dynamic content, such as lists where items are added or removed after the page loads. By checking the event target, you can determine which specific child element triggered the event and respond accordingly. For example, if you have a list of items and want to handle clicks on each item, you can add a single listener to the parent list element. This method reduces memory usage and simplifies code maintenance, making it an efficient solution for managing events in large or changing DOM structures. Following best practices in event handling ensures that your code is efficient, maintainable, and accessible. Avoiding inline event handlers, such as using the onClick attribute directly in HTML, keeps your JavaScript separate from your markup, making it easier to manage and debug. Removing event listeners when they are no longer needed prevents memory leaks and improves performance, especially in long-running applications. Using the prevent default method for form submissions allows you to validate data before sending it to the server, enhancing user experience. Finally, prioritizing accessibility means designing interactive elements that work with keyboard navigation and screen readers, ensuring that all users can interact with your application effectively. Event handling is a fundamental aspect of JavaScript programming, enabling the creation of interactive and responsive web applications. By mastering the add event listener method and understanding the various types of events, you can build dynamic behaviors that enhance user engagement. Applying best practices ensures that your code remains efficient and maintainable over time. As you continue to explore JavaScript, remember that event handling is not just about responding to user actions, but also about creating a seamless and accessible experience for all users. With practice and attention to detail, you can develop powerful applications that meet the needs of modern web development. Error handling is a critical aspect of building reliable and user-friendly JavaScript applications. Without proper error handling, even minor issues can lead to application crashes, which can frustrate users and damage the overall experience. By implementing error handling mechanisms, developers can prevent unexpected failures and ensure that the application continues to function even when problems arise. This not only improves the user experience, but also allows the application to degrade gracefully, meaning it can continue operating in a limited capacity rather than completely failing. For example, if a feature encounters an error, the application can inform the user and offer alternative solutions rather than shutting down entirely. In JavaScript, errors can be categorized into three main types. The first is syntax errors, which occur when the code violates the language's rules. Examples include missing semicolons, incorrect brackets, or typos in keywords. These errors are typically caught during the parsing phase and prevent the code from running at all. The second type is runtime errors, which happen during the execution of the code. These might include accessing a variable that hasn't been declared or calling a function that doesn't exist. Unlike syntax errors, runtime errors are not detected until the code is actually run. The third type is logical errors, which are the most challenging to identify. These occur when the code runs without any issues, but produces incorrect results due to flawed logic, such as a miscalculation in a function or an incorrect conditional check. One of the most powerful tools for handling errors in JavaScript is the try-catch statement. The try block contains the code that might throw an error, while the catch block is designed to handle any exceptions that occur. For example, if a function attempts to access a property of an undefined variable, the try block will execute until the error is encountered, and the catch block will then take over to manage the situation. This structure allows developers to control the flow of the program and prevent unhandled exceptions from crashing the entire application. By using try-catch, developers can ensure that errors are addressed in a structured way, making the application more resilient and easier to debug. In addition to try and catch, JavaScript provides a finally block that executes after the try or catch blocks, regardless of whether an error occurred. This is particularly useful for cleanup tasks, such as closing files, releasing resources, or resetting variables. For instance, if a function opens a database connection and an error occurs during its execution, the finally block ensures that the connection is properly closed, preventing memory leaks or resource exhaustion. The finally block is guaranteed to run, even if the try or catch blocks return early or throw another error. This makes it an essential component for ensuring that critical operations are completed, no matter the outcome of the surrounding code. JavaScript allows developers to create custom error objects to provide more specific and meaningful error messages. This is done using the error constructor, such as new error message, which creates a basic error object. However, for more specialized scenarios, developers can extend the built-in error class to create custom error types. For example, a class named custom error could be defined to encapsulate specific error conditions, such as validation failures or network issues. By using custom errors, developers can distinguish between different types of failures and handle them more effectively. This approach also improves code readability and makes it easier to debug and maintain complex applications. Modern browsers come equipped with powerful developer tools that are essential for debugging JavaScript code. Tools like Chrome Dev Tools or Firefox Developer Tools provide a comprehensive environment for inspecting, testing, and troubleshooting code. These tools allow developers to set breakpoints, step through code line by line, and examine variable values in real time. For example, a developer can pause execution at a specific line of code to observe the state of the application and identify potential issues. By leveraging these tools, developers can gain deeper insights into how their code behaves and quickly resolve errors that might otherwise be difficult to track down. The console in JavaScript is a vital resource for debugging, offering a variety of methods to output information. The console log method is commonly used to print general messages or variable values, making it useful for tracing the flow of execution. When an error occurs, console error is ideal for displaying error messages, as it often highlights them in the console with a distinct style. Similarly, console warn is used for warnings, and console info provides informational logs. These methods help developers quickly identify and address issues by providing clear, structured feedback about the application's behavior. Effective debugging in JavaScript involves a combination of techniques that help identify and resolve issues efficiently. One of the most straightforward methods is using console.log to track the values of variables and the flow of execution. By strategically placing logs in the code, developers can pinpoint where things go wrong. Another technique is setting breakpoints in the browser's developer tools, which allows the code to pause at specific points, enabling a detailed inspection of the application's state. Additionally, examining stack traces provides insight into the sequence of function calls that led to an error, making it easier to locate the root cause. These practices, when combined, form a robust approach to debugging and troubleshooting. Best practices for error handling in JavaScript emphasize precision, clarity, and reliability. One key principle is to handle specific errors rather than using a generic catch block that might inadvertently catch unexpected exceptions. This ensures that errors are addressed in a targeted manner, reducing the risk of masking unrelated issues. Logging errors is another critical practice, as it provides valuable data for debugging and monitoring the application's performance over time. For asynchronous code, such as promises or async await, it's essential to use try-catch blocks to manage errors that may occur during asynchronous operations. By following these best practices, developers can create more maintainable and robust applications that are easier to debug and update. In conclusion, mastering error handling is essential for building stable and reliable JavaScript applications. By understanding the different types of errors and implementing structured approaches like try-catch, developers can prevent crashes and ensure a smoother user experience. Debugging tools and techniques such as browser dev tools and console methods are invaluable for identifying and resolving issues efficiently. Prioritizing structured error management not only improves the application's performance, but also makes the code base more maintainable and easier to scale. Ultimately, these practices contribute to the long-term success of any JavaScript project. JavaScript has evolved significantly over the years, and one of the most transformative updates came with the release of E6, also known as ECMAScript 2015. This version introduced a wide range of features that reshaped how developers write and structure their code. Modern JavaScript builds on these updates, offering tools like arrow functions, modules, and more. These advancements make code more readable, easier to maintain, and more efficient to write. By embracing these features, developers can create cleaner, more organized code that scales better for complex applications. E6 brought several key features that have become foundational in modern JavaScript development. The introduction of let and const for block-scoped variables addressed long-standing issues with the var keyword, which had function-level scope and unexpected behavior. Arrow functions provide a more concise syntax for writing functions, while also capturing the lexical context of this, making them ideal for callbacks. Template literals allow for easier string manipulation with multi-line support and embedded expressions. Destructuring simplifies the extraction of data from arrays and objects. And the spread and rest operators offer powerful ways to work with arrays and objects by expanding or collecting elements. These features collectively enhance productivity and code clarity. Block-scoped variables like let and const are a critical improvement over the traditional var keyword. Let allows variables to be scoped to the nearest block, such as within loops or conditional statements, reducing the risk of unintended side effects. Const is used for variables that should remain immutable once assigned, ensuring that their values cannot be reassigned. This approach avoids common pitfalls associated with var, such as hoisting and variable leakage. By using let and const, developers can write more predictable and maintainable code, especially in larger projects where variable scope can become complex. Arrow functions are a game changer for writing concise and readable code. Their syntax, which uses the arrow symbol, eliminates the need for the function keyword and allows for shorter function definitions. For example, a function like function add b return a plus b can be written as a b equals a plus b. This simplicity is particularly useful in scenarios like callback functions or when working with higher order functions. Another key benefit is the lexical binding of this, which means arrow functions inherit the this value from their surrounding context. This makes them a reliable choice for methods in objects or event handlers where the context might otherwise be lost. Template literals revolutionize string handling in JavaScript by allowing multi-line strings and dynamic content insertion. Instead of using quotation marks, developers can use backticks to create strings that span multiple lines without needing escape characters. For instance, a string like hello plus name plus becomes hello name using template literals. This not only improves readability, but also makes it easier to embed variables and expressions directly into strings. Whether building dynamic UI elements or generating complex text outputs, template literals provide a more intuitive and efficient way to work with strings. Destructuring assignment is a powerful feature that simplifies the process of extracting values from arrays or objects. For example, instead of accessing properties one by one, developers can use syntax like const name age equals user to directly pull out specific fields. This approach reduces boilerplate code and makes the intent of the code clearer. Destructuring also works with nested objects and arrays allowing for efficient data manipulation. By using this technique, developers can write more compact and expressive code, especially when dealing with complex data structures like API responses or configuration objects. The spread and rest operators are versatile tools for working with arrays and objects. The spread operator, represented by 3 dots, allows elements of an array or properties of an object to be expanded into another structure. For example, array 1, array 2 combines 2 arrays seamlessly. The rest operator, on the other hand, collects multiple arguments into an array, making it easy to handle variable numbers of inputs. These operators are particularly useful for merging data, copying objects, or passing arguments to functions. Their flexibility makes them indispensable for tasks like data transformation and function parameter handling. E6 introduced a more structured approach to object-oriented programming through the class keyword. Developers can now define classes with methods and constructors, making it easier to create and manage objects. The extends keyword enables inheritance, allowing one class to build upon another, which simplifies code reuse and organization. While JavaScript has always been prototype-based, classes provide a more familiar syntax for developers coming from other object-oriented languages. This feature streamlines the creation of complex applications by promoting a more modular and maintainable code base. Modules and the import-export system are essential for organizing and reusing code in modern JavaScript applications. By using import and export, developers can split their code into separate files, making it easier to manage large projects. Named exports allow specific functions, variables, or classes to be exported, while default exports provide a single primary export per file. This modular approach enhances code readability, reduces conflicts, and promotes collaboration among teams. Whether building a small script or a large-scale application, modules are a cornerstone of efficient and scalable development. In summary, E6 and modern JavaScript have introduced a wealth of features that have transformed the language into a more powerful and expressive tool. From block-scoped variables and arrow functions to modules and classes, these updates address long-standing pain points and improve the overall developer experience. By leveraging these tools, developers can write cleaner, more efficient code that is easier to read, maintain, as the web continues to evolve. Mastering these features is essential for building robust and future-proof applications. Good day, everyone. Today, we will explore arrow functions, a powerful feature introduced in E6, which stands for ECMAScript 2015. Arrow functions provide a more concise way to write function expressions in JavaScript. Unlike traditional functions, they automatically bind the keyword this to the surrounding context, which helps avoid common issues when working with callbacks or event handlers. This makes them ideal for short, one-liner functions where the code is straightforward. By using arrow functions, we can write cleaner and more readable code, especially when dealing with simple operations that don't require complex logic. Let's compare the syntax of traditional functions with arrow functions. A traditional function might look like this. Function add a plus b, return a plus b. With an arrow function, the same operation becomes const add equals. A b equals a plus b. Notice how we eliminate the function keyword and the return statement when the function is a single expression. This simplification makes the code shorter and easier to understand. Additionally, parentheses are optional if there is only one parameter, so we can write const square equals x times x. However, when there are multiple parameters or no parameters, parentheses are required. This flexibility allows developers to choose the most readable format for their code. Lexical scope is a fundamental concept in JavaScript that determines how variables are accessed based on their position in the code. When a variable is declared in an outer scope, it is available in inner scopes, which is known as lexical scoping. For example, if a variable is defined in a parent function, it can be accessed by nested functions within that parent function. This behavior is different from dynamic scoping, where the context of the call determines variable access. Understanding lexical scope helps us write predictable and maintainable code, as we can anticipate where variables are available and how they interact with different parts of the program. One of the most significant advantages of arrow functions is how they handle the keyword this. Unlike traditional functions, which have their own this binding, arrow functions inherit this from the enclosing lexical scope. This means that the value of this inside an arrow function is determined by the surrounding code, not by how the function is called. This behavior is particularly useful in callbacks or event handlers, where the context of this can change traditional function inside a method. This might refer to the global object or undefined, but an arrow function ensures that this remains consistent with the surrounding code. This eliminates the need for workarounds like binding or using that equals this. Arrow functions are especially useful in scenarios where we need to write concise and context-aware code. They are commonly used as callbacks in array methods like map, filter, and reduce, where the function's purpose is clear and straightforward. For example, when mapping over an array, an arrow function can transform each element without the need for additional syntax. They also help maintain this context in object methods, which is crucial for avoiding errors in object-oriented programming. Additionally, arrow functions are great for inline functions where the logic is minimal, making the code more readable and reducing the cognitive load for developers who read the code. While arrow functions offer many benefits, they also have limitations that developers should be aware of. First, they cannot be used as constructors because they do not have their own this binding. This means we cannot use the new keyword with an arrow function to create instances of a class. Second, arrow functions do not have access to the arguments object, which is a special variable in traditional functions that contains all the arguments passed to the function. Instead, developers must use REST parameters to achieve similar functionality. Finally, arrow functions are not suitable for methods that require a dynamic this context, such as event handlers that need to reference the element that triggered the event. In such cases, traditional functions are more appropriate. To make the most of arrow functions, it's important to follow best practices. Use arrow functions for short, context-aware functions where the code is simple and that this binding is critical. For example, when writing a callback that needs to access the surrounding this, an arrow function is ideal. However, reserve traditional functions for methods that require dynamic this, such as when working with object-oriented patterns or when the function's context might change. Always prioritize readability and consistency in your code. If an arrow function makes the code harder to understand, it's better to use a traditional function. By striking the right balance, you can write efficient and maintainable JavaScript. In summary, arrow functions offer a concise syntax and lexical this binding, making them a valuable tool in JavaScript development. They simplify the writing of functions, especially in scenarios where the context of this is important. Lexical scope ensures that variables are accessible based on their position in the code, which contributes to predictable behavior. However, it's essential to choose between arrow functions and traditional functions based on the specific requirements of your code. Understanding the strengths and limitations of each helps you make informed decisions that improve the quality of your code. Mastering arrow functions and lexical scope can significantly enhance your efficiency as a JavaScript developer. Understanding how this behaves in different contexts helps you avoid common pitfalls, such as unexpected this values in callbacks or event handlers. By applying these concepts, you can write cleaner, more maintainable code that is easier to read and debug. As you continue to explore JavaScript, remember that the key to writing high-quality code lies in choosing the right tools for the job and maintaining a deep understanding of how the language works under the hood. Template literals are a powerful feature in JavaScript that allow you to create strings with embedded expressions. Unlike traditional strings that use double or single quotes, template literals use backticks. This makes it easier to include variables and expressions directly within the string. For example, you can write a dynamic string like hello, name, where the value of the variable name is inserted automatically. This eliminates the need for concatenation with the plus operator, making your code cleaner and more readable. Additionally, template literals support multi-line strings without requiring escape characters, which is especially useful when working with HTML or complex text structures. The syntax for template literals is straightforward. You start with backticks and then use the $sign and curly braces to embed expressions. For instance, string expression allows you to dynamically insert values into your string. One of the key advantages of template literals is their ability to handle multi-line strings seamlessly. You can write a string that spans multiple lines without using special characters like backslashes or newlines. Another advanced feature is tagged templates, which let you pass the string to a function for processing. This is useful for tasks like formatting, internationalization, or even creating custom string handlers. By using template literals, you can avoid the cumbersome process of string concatenation, making your code more efficient and easier to maintain. Destructuring is a technique in JavaScript that simplifies the process of extracting values from arrays or objects. Instead of accessing elements or properties one by one, you can use destructuring to assign them directly to variables. This is particularly useful when working with complex data structures, as it reduces the amount of boilerplate code needed. For example, if you have an array like 1, 2, you can extract its elements into variables A and B using const A, B equals 1, 2. This approach makes your code more concise and easier to understand, especially when dealing with nested data. Destructuring is a fundamental concept that enhances code readability and efficiency. When working with arrays, destructuring allows you to extract elements by their index. For instance, const first, second equals array assigns the first and second elements of the array to the variables first and second. You can also skip elements by leaving a space between commas, like const first, third equals array, to skip the second element. The rest operator, represented by 3 dots, lets you capture the remaining elements of an array, as in const first, rest equals array. This is helpful when you want to separate the first element from the rest of the array. Additionally, destructuring can be used to swap variables without needing a temporary variable, such as let A equals 1, B equals 2, A B equals B. These features make array manipulation more intuitive and efficient. Destructuring objects allows you to extract properties based on their names, making it easier to work with complex data structures. For example, if you have an object like name, Alice, age 30, you can extract the name and age properties into variables using const name, age equals person. This eliminates the need to access each property individually. You can also rename variables during extraction, such as const name, full name equals person, which is useful when the property name conflicts with a variable name. Default values can be set in case a property is missing, like const city equals unknown equals person. Furthermore, nested destructuring lets you access properties within nested objects, such as const address, city equals person. These capabilities make object handling more flexible and streamlined. Template literals and destructuring have numerous practical applications in real-world JavaScript development. For instance, when generating dynamic HTML content, you can use template literals to embed variables directly into the string, such as divinrhtml equals h1 $title/h1. This avoids the need for repetitive concatenation. When working with API responses, destructuring simplifies accessing specific data, like const data equals await fetch. Function parameters can also benefit from destructuring, allowing you to extract values directly from an object, as in function print name, age. These techniques not only make your code more readable, but also reduce the risk of errors by minimizing nested property access. Incorporating these features into your workflow can significantly enhance productivity and code quality. In summary, template literals and destructuring are essential tools in modern JavaScript development. Template literals improve string manipulation by supporting multi-line strings, dynamic content, and cleaner syntax. Destructuring simplifies data extraction from arrays and objects, making your code more concise and maintainable. Together, these features reduce the need for repetitive code and enhance readability, leading to more efficient and scalable applications. By practicing these techniques in real-world scenarios, you can deepen your understanding and become more proficient in writing clean, effective JavaScript. JavaScript modules are reusable code blocks that encapsulate functionality, allowing developers to organize their code in a structured and manageable way. By splitting code into separate files, modules help maintain a clean and efficient code base, making it easier to navigate and update. This approach is particularly useful in large projects where multiple developers collaborate. Modules use the export and import keywords to share and reuse code across different files, promoting a modular and scalable development process. These features are part of the EASE 6+ standards, which have become essential for modern JavaScript development, enabling more efficient and maintainable code. Exporting code in JavaScript allows you to make specific variables, functions, or classes available for use in other files. Named exports are useful when you want to export multiple items from a single file, such as a constant like pi or a function like add. For example, you might write export const pi equals 3.14 to share a value, or export function adda b return a plus b to share a function. Default exports, on the other hand, are used when a file has a single primary item to export, such as a main function or class. You can also combine exports by using export pi add to include multiple named exports in one statement, making it easier to manage and import related code. Importing code in JavaScript allows you to access and use exported functionality from other modules. For named imports, you specify the exact names of the items you want to use, such as import pi, add from /math.js, to bring in the pi constant and add function. Default imports are simpler when a module has a single primary export, like import add from /math.js, which directly references the default function. If you need to import all exports from a module, you can use import as math from /math.js to access everything under a single namespace. These import statements help keep your code organized and prevent naming conflicts by explicitly defining what you need from other files. The syntax for modules in JavaScript involves using export statements to define what code is shared and import statements to specify what is used from other modules. Unlike older methods, modules are loaded at runtime, which means the browser or runtime environment processes them dynamically as the application runs. This approach offers more flexibility and control over how code is executed. Additionally, when importing files, it is often necessary to include the file extension, such as JS, to ensure the correct module is loaded. This practice helps avoid ambiguity, especially in projects with multiple files or complex directory structures. Modules are widely used in modern JavaScript development for several key reasons. They help organize large applications by breaking them into logical, manageable files, which improves readability and maintainability. Reusing functions, classes, or constants across projects becomes much simpler with modules, reducing redundancy and promoting code efficiency. By managing dependencies through modules, developers can avoid polluting the global scope, which minimizes the risk of naming conflicts and improves the overall stability of the application. Additionally, modules enhance code organization, making it easier for teams to collaborate and for individual developers to maintain and update their code over time. To make the most of JavaScript modules, it is important to follow best practices. Use named exports when you have multiple items to share, such as several functions or constants, and default exports for a single primary item, like a main class or function. Keeping modules focused on a single responsibility ensures that each file has a clear purpose, making the code base easier to understand and maintain. Avoiding circular dependencies, where modules import each other in a loop, is crucial to prevent errors and ensure smooth execution. Finally, using relative paths for imports, such as /math JS instead of absolute paths, helps maintain clarity and ensures that the code works consistently across different environments. Modules are a cornerstone of modern JavaScript development, enabling scalable and modular code structures that are essential for building complex applications. The export and import statements are fundamental tools for organizing code, allowing developers to share and reuse functionality efficiently. Mastering modules not only improves the quality of your code, but also enhances collaboration by making it easier for teams to work together on large projects. By practicing with modules in real-world scenarios, such as building a web application or a library, you can reinforce your understanding and develop the skills needed to create well-structured, maintainable JavaScript code. Good morning, everyone. Today, we are diving into the world of asynchronous JavaScript, a critical concept for building efficient and responsive web applications. We will start by understanding the basics of asynchronous programming, then move on to the role of callbacks in handling non-blocking operations. You will see practical examples that demonstrate how these concepts are applied in real-world scenarios. Finally, we will explore common challenges developers face and the best practices to overcome them. Let's get started. JavaScript is inherently a single-threaded language, which means it executes code sequentially, line by line, in a synchronous manner. However, this can lead to performance issues when dealing with tasks that take time, such as fetching data from a server or reading a file. Asynchronous JavaScript allows these long-running operations to occur without freezing the browser. For example, while waiting for an API call to complete, the browser can still handle user interactions or other tasks. This non-blocking behavior is essential for creating smooth and efficient user experiences. The primary reason to use asynchronous code is to prevent the user interface from becoming unresponsive during long operations. Imagine a scenario where a web page is waiting for a large file to download without asynchronous handling. The entire browser would freeze, leading to a poor user experience. Asynchronous code enables the browser to continue processing other tasks, such as updating the UI or responding to user input. This is particularly important for I/O operations, like fetching data from a server, which can take seconds. Additionally, asynchronous programming is the backbone of real-time applications, such as chat platforms or live updates, where interactions need to happen instantly without waiting for previous tasks to finish. Callbacks are a fundamental concept in JavaScript, serving as functions that are passed as arguments to other functions. They are executed once a specific task is completed, allowing developers to handle asynchronous operations. For instance, when you call a function to fetch data from an API, you can pass a callback function that will be invoked once the data is retrieved. This pattern is widely used in JavaScript to manage tasks that take time, such as reading a file or setting a timer. Callbacks essentially act as a way to signal that a particular operation has finished, enabling the next steps in the program to proceed. Let me walk you through a few examples of the callback pattern. The first is the set timeout function, which delays the execution of a function. Here, the arrow function, console log done, is a callback that runs after 1 second. Another example is the fetch data function, which might take a callback as an argument to handle the data once it is retrieved. In Node.js, the fs read file method uses a callback to process the contents of a file once it is read. These examples illustrate how callbacks are used to manage asynchronous tasks, ensuring that the program doesn't wait for a task to complete before moving on to the next one. While callbacks are powerful, they can lead to a problem known as callback hell or the pyramid of doom. This occurs when multiple callbacks are nested within each other, creating a structure that is difficult to read and maintain. For example, a function that calls another function, which in turn calls another, and so on, results in deeply nested code. This not only makes the code harder to debug, but also increases the risk of errors. Imagine trying to follow a chain of 10 nested callbacks. Each level adds complexity, making the code less intuitive and more error-prone. This is why it's crucial to manage callbacks carefully. To avoid the pitfalls of callback hell, there are several best practices to follow. First, keep callbacks small and focused on a single task. This makes the code easier to understand and test. Second, use named functions instead of anonymous ones, as as they improve readability and allow for better debugging. Finally, avoid deep nesting by breaking down complex operations into smaller, reusable functions. For instance, instead of nesting multiple callbacks, you can refactor the code into separate functions that handle specific parts of the process. These practices will help you write cleaner, more maintainable asynchronous code. Asynchronous programming is used in a variety of scenarios. One common use case is fetching data from an API, such as retrieving user information from a web service. Another is handling user input events, like click or keyboard events, which require the program to respond without blocking other operations. Delayed execution, such as using set timeout to run a function after a specific time, is another example. In Node.js, file system operations like reading or writing files often rely on asynchronous callbacks to prevent the server from freezing during these tasks. These use cases highlight the versatility of asynchronous JavaScript in different environments. Despite their usefulness, callbacks have limitations. One major issue is the lack of built-in error handling. Developers must manually check for errors in each callback, which can be tedious and error-prone. Chaining multiple asynchronous operations with callbacks also becomes cumbersome, as each step requires a nested function. This makes it difficult to manage complex workflows, such as sequential API calls or data processing pipelines. These challenges led to the development of more advanced asynchronous patterns like promises and async await, which we will explore in future sessions. To recap, asynchronous JavaScript is essential for creating responsive and efficient applications. Callbacks, while foundational, have their limitations and are best used with care to avoid complexity. Understanding callbacks is a critical step toward mastering modern asynchronous techniques like promises and async await. As we move forward, we will build on this foundation to explore more advanced tools that simplify handling asynchronous operations. Remember, the key to effective asynchronous programming lies in writing clean, maintainable code that balances functionality with readability. Let's keep this in mind as we continue our journey into JavaScript's asynchronous capabilities. Promises are a fundamental concept in JavaScript for managing asynchronous operations. They represent the eventual completion or failure of an action that takes time, such as fetching data from a server or reading a file. Unlike traditional callbacks, which can lead to nested and hard-to-read code, promises provide a more structured and readable approach. A promise can exist in one of three states: pending, fulfilled, or rejected. The pending state is when the operation is still in progress. Once the operation completes successfully, the promise moves to the fulfilled state, carrying a value. If the operation fails, it enters the rejected state, carrying an error message or reason. This state model helps developers handle asynchronous tasks more predictably and maintainably. Let me break down the three states of a promise. The first is the pending state, which is the initial state when an asynchronous operation starts. During this time, the outcome is unknown. The second state is fulfilled, which occurs when the operation completes successfully. For example, if you request data from an API and it returns, the promise is fulfilled and you can access the data. The third state is rejected, which happens when an error occurs during the operation. This could be a network failure, an invalid input, or any other issue that prevents the operation from succeeding. Understanding these states is crucial for writing robust, asynchronous code that can handle both success and failure scenarios gracefully. Creating a promise involves using the promise constructor, which takes a function as an argument. This function has two parameters: resolve and reject. The resolve function is called when the asynchronous task completes successfully, and the reject function is called when the task fails. For instance, if you simulate a delayed operation with set timeout, you might call resolve after a few seconds to indicate success, or reject if an error occurs. This structure allows you to encapsulate any asynchronous logic, such as fetching data or processing files, into a promise. By returning a promise, you can chain subsequent operations or handle errors using then and catch. This makes it easier to manage complex workflows without deeply nested callbacks. Chaining promises is a powerful way to handle sequential asynchronous operations. The then method is used to handle the resolved value of a promise, allowing you to perform actions after the previous step completes. For example, you might fetch data from an API, process it, and then display it on a web page. If any step in the chain fails, the catch method can intercept the error and handle it, preventing the program from crashing. Chaining ensures that each step depends on the previous one, making the code more organized and easier to follow. It also avoids the callback hell that can occur when using nested callbacks, leading to cleaner and more maintainable code. Async and await are modern JavaScript features that simplify working with promises. An async function is declared with the async keyword, and it automatically returns a promise. Inside an async function, the await keyword pauses the execution of the function until the promise it is waiting for is resolved. This makes asynchronous code look and behave like synchronous code, which is easier to read and write. For example, instead of using then to handle a promise, you can simply assign the result of an await expression to a variable. This eliminates the need for complex chaining and makes the flow of the program more intuitive. The syntax for async and await is straightforward. To create an async function, you use the async keyword before the function declaration. For example, async function fetch data. Inside the function, you can use the await keyword before a promise to wait for its resolution. This pauses the function until the promise is fulfilled or rejected. When using await, you can combine it with try-catch blocks to handle errors, just like with synchronous code. This approach makes error handling more consistent and reduces the complexity of managing multiple promise chains. By using async and await, developers can write asynchronous code that is both readable and easy to debug. Error handling is a critical aspect of asynchronous programming, and try-catch blocks are essential for managing errors in async functions. When using await, any error that occurs in the promise will throw an exception, which can be caught using a try-catch structure. For example, if a network request fails, the code inside the catch block will execute, allowing you to log the error or take corrective action. This approach is more intuitive than using catch on a promise chain, as it allows you to handle errors in the same context where the asynchronous operation occurs. By wrapping your async code in a try block, you ensure that any exceptions are properly caught and handled, improving the reliability of your applications. Promises and async await are both powerful tools for handling asynchronous operations, but they have different use cases and syntax. Promises rely on methods like then and catch to handle success and failure, requiring chaining for sequential operations. This can lead to nested callbacks if not managed carefully. Async await, on the other hand, provides a more linear and readable structure by allowing you to write asynchronous code that looks like synchronous code. However, they are interoperable. Async await can work with any promise-based API, and promises can be used in async functions. Choosing between them depends on the complexity of the task and the developer's preference for code style. Both approaches are widely used in modern JavaScript development. Promises and async await are commonly used in real-world scenarios, such as fetching data from APIs, handling file I/O operations, and implementing delayed execution. For example, the fetch function in JavaScript returns a promise, making it easy to retrieve data from a server. File I/O operations, like reading or writing files, can also be managed using promises to avoid blocking the main thread. Delayed execution, such as using set timeout with a promise, allows you to schedule tasks to run after a specific time. These use cases demonstrate how promises and async await enable developers to write efficient, non-blocking code that improves the performance and responsiveness of applications. To make the most of promises and async await, it's important to follow best practices. Always handle errors using try-catch blocks or catch to prevent unhandled rejections. Avoid mixing await with then in the same code block, as this can lead to confusion and bugs. For parallel operations, use promise-all to execute multiple promises simultaneously and wait for all of them to complete. This is particularly useful when fetching data from multiple APIs at once. Additionally, keep your async functions focused on a single responsibility to maintain clarity and reduce complexity. By adhering to these practices, you can write more reliable and maintainable asynchronous code. In conclusion, promises and async await are essential tools for modern JavaScript development. They provide a structured and readable way to handle asynchronous operations, making it easier to write complex applications. By understanding the states of a promise, how to create and chain them, and how to use async await for cleaner code, developers can significantly improve the efficiency and maintainability of their projects. Practicing these concepts in real-world scenarios will help solidify your understanding and enable you to build more robust and scalable applications. Embrace these features to unlock the full potential of asynchronous programming in JavaScript. Application Programming Interfaces, or APIs, are the essential tools that allow different software systems to communicate with each other. Imagine you have a website that needs to get weather updates or display social media posts. APIs act as the bridge that lets your JavaScript code interact with external services to retrieve or send data. There are various types of APIs, such as REST, GraphQL, and SOAP. For this session, we will focus on REST because it is the most widely used and straightforward approach for web developers. Examples of APIs include weather data services that provide current conditions, social media platforms that let you fetch user feeds, or payment gateways that process transactions. Understanding APIs is crucial for building dynamic and interactive web applications. The Fetch API is a modern and powerful way to make HTTP requests in JavaScript. It replaces older methods like XML HTTP request, which required more complex code to handle asynchronous operations. The Fetch API uses promises, which make it easier to manage asynchronous tasks by chaining methods like then and catch. This approach simplifies handling responses and errors in a more readable way. The Fetch API supports all the standard HTTP methods, including GET to retrieve data, post to send data, put to update resources, and delete to remove data. These methods allow your JavaScript code to interact with servers in a flexible and efficient manner. The core function of the Fetch API is fetcherl options, where URL is the endpoint you want to access, and options is an object that specifies additional parameters. For example, if you want to fetch data from a URL like https://API example com/data, you can use the fetch function. The response from the server is a promise, which you can chain with then to process the data. In the example, after fetching the data, we use response JSON to convert the response into a JavaScript object. This allows you to work with the data in your code, such as logging it to the console. The options object can include headers, the HTTP method, and a body for sending data. When working with the Fetch API, it is important to handle the response correctly. The response object has a property called OK, which is true if the HTTP status code is between 200 and 299, indicating success. If the status code is outside this range, the OK property will be false, and you should handle the error. To extract the data from the response, you can use methods like JSON to parse JSON data or text for plain text. For instance, after making a fetch request, you can check if response OK is true before proceeding to parse the data. This ensures that your code only processes valid responses and avoids errors from failed requests. Error handling is a critical part of working with APIs. The Fetch API can throw errors due to network issues, server errors, or invalid responses. To catch these errors, you can use the catch method, which is chained to the fetch promise. For example, if a request fails or the server returns an error, the catch block will execute, allowing you to log the error or display a user-friendly message. It is important to avoid silent failures by ensuring that errors are properly logged. This helps in debugging and ensures that your application can respond gracefully to unexpected issues. Always include error handling to make your code more robust and user-friendly. When sending data to a server, you need to use the post method. The fetch function allows you to specify the method in the options object, along with headers and a body. For example, to send a post request to https://API example.com/submit, you set the method to post and include a body with the data you want to send. The body must be a string, so you use JSON stringify to convert a JavaScript object into a JSON string. Additionally, you should set the headers to specify the content type, such as application/JSON for JSON data. Properly configuring the headers and body ensures that the server can correctly interpret the data being sent. This is essential for actions like submitting forms or creating new resources on the server. Using async and await with the Fetch API can make your code cleaner and easier to read. The async keyword allows you to define a function that returns a promise, and the await keyword pauses the execution of the function until the promise is resolved. This eliminates the need for chaining, then methods, and makes the code more straightforward. For example, you can write an async function that uses await to fetch data from an API. If the response is not successful, you can throw an error, which is then caught in a try-catch block. This approach simplifies error handling and makes the code more maintainable, especially for complex asynchronous operations. Many APIs require authentication to ensure that only authorized users can access their resources. Common methods include API keys, OAuth tokens, or other authentication schemes. To include authentication in a fetch request, you add headers to the options object. For example, if an API uses a bearer token, you can set the authorization header to bearer YOURTOKN. Alternatively, some APIs might require an XAPI key header with your unique key. Including these headers in your requests ensures that the server can verify your identity and grant access to the required data. Always follow the API documentation to determine the correct authentication method and headers to use. Following best practices when working with APIs can significantly improve the reliability and performance of your code. Always use try-catch blocks to handle errors gracefully and prevent unhandled exceptions. Validating and sanitizing API responses is also important to ensure the data is in the expected format and free from malicious content. Limiting the number of API calls can help avoid hitting rate limits and improve performance. Additionally, consider using libraries like Axios for more advanced features, such as automatic request interception or built-in error handling. These practices help create more robust and efficient applications that can handle real-world scenarios effectively. In summary, APIs are fundamental for integrating external data and services into your applications. The Fetch API provides a modern and efficient way to make HTTP requests using promises or async await. Always handle errors and validate responses to ensure your code is reliable. Practicing with real APIs like JSON placeholder or Open Weather Map can help you gain hands-on experience. By understanding how to use the Fetch API effectively, you can build dynamic and interactive web applications that leverage the power of external data sources. Keep exploring and experimenting with different APIs to enhance your skills as a JavaScript developer. Node.js provides powerful built-in modules that allow developers to interact with the file system, making it easier to handle tasks like reading, writing, and managing files and directories. The key modules involved are the file system module, which we'll explore in detail on the next slide, the path module for handling file paths in a cross-platform way, and the OS module for accessing system-specific information. These modules are essential for building applications that need to work with files and system resources. Whether you're creating a simple script or a complex server-side application, the file system module, often referred to as FS, offers a wide range of methods for performing file operations. For synchronous operations, you can use FS, read file sync, and FS, write file sync, which block the execution of your code until the file is fully read or written. This is useful for small tasks where simplicity is more important than performance. For larger applications, asynchronous methods like FS, read file, and FS, write file are preferred because they allow your code to continue running without waiting for the file operation to complete. These methods are particularly valuable when dealing with I/O-heavy tasks, as they prevent the event loop from being blocked. The FS module also includes functions for creating, deleting, and traversing files and directories, making it a versatile tool for file management. The path module is designed to handle the complexities of file paths across different operating systems. Since file paths can vary significantly between Windows, macOS, and Linux, the path module provides functions like path join and path resolve to create and normalize paths in a way that works seamlessly on any platform. For example, path join combines multiple path segments into a single string, while path resolve converts a relative path into an absolute one. Other useful methods include path dir name, which extracts the directory name from a path, and path base name, which retrieves the file name. By using these methods, developers can avoid errors caused by hard-coding platform-specific paths and ensure their applications are more portable and reliable. Node.js supports two primary module systems: CommonJS, which is the default, and Ease modules, which requires configuration in the package JSON file. CommonJS uses the require function to import modules, making it straightforward for developers familiar with older JavaScript practices. Ease modules, on the other hand, utilize the import and export keywords, aligning with modern JavaScript standards. This dual system allows developers to choose the approach that best fits their project's needs, whether they're working on a legacy code base or a new application that leverages the latest JavaScript features. Understanding both systems is crucial for navigating the Node.js ecosystem effectively. creating and using modules in Node. JS involves exporting and importing functions, objects, or values. In CommonJS, you can export a module using module exports, while in Ease modules, you use the export keyword. For example, a module might export a function that calculates the sum of two numbers, which can then be imported into another file using require or import, depending on the module system. This modular approach promotes code reuse, making it easier to organize and maintain large applications. By breaking down code into smaller, focused modules, developers can improve readability and simplify testing and debugging. The module resolution process in Node. JS determines how the runtime locates and loads modules. When you call require, Node, JS searches for the module in a specific order. First in the current directory, then in the Node modules folder, and finally in global paths. This hierarchical search ensures that local modules take precedence over globally installed ones. Additionally, require resolves modules based on file extensions, such as JS, JSON, or Node, which helps in loading the correct file type. The package JSON file plays a key role here by defining the entry point for a module, allowing developers to specify which file should be loaded when a directory is required. Beyond the file system and path modules, Node.js includes several built-in modules that enhance its functionality. The HTTP module, for instance, is used to create web servers and handle HTTP requests and responses. The OS module provides information about the operating system, such as the number of CPUs, memory usage, and the platform's architecture. The process module allows access to environment variables, command line arguments, and other runtime information, making it invaluable for configuring and debugging applications. These modules are fundamental for building robust server-side applications that interact with the system and network. In summary, the file system, module, and path module are essential for handling file operations and ensuring cross-platform compatibility. The module system in Node.js, whether CommonJS or Ease modules, enables efficient code reuse and organization. By leveraging asynchronous methods, developers can improve performance, while modularizing code leads to cleaner, more maintainable projects. Following best practices, such as using these techniques consistently, will help you build scalable and reliable node. JS applications. JavaScript offers a robust framework for object-oriented programming, and this session will delve into advanced concepts that elevate your understanding of the language. We will explore Ease 6 and later features that modernize object-oriented practices alongside essential design patterns. Abstraction allows us to simplify complex systems by hiding internal details. Encapsulation ensures data safety by restricting direct access, and inheritance enables code reuse through hierarchical relationships. These principles form the backbone of scalable and maintainable JavaScript applications. In JavaScript, the class keyword provides a clear and structured way to define objects, making it easier to implement object-oriented principles. When creating a class, you can use the extends keyword to establish inheritance, allowing a child class to inherit properties and methods from a parent class. The super keyword is crucial for calling the parent class constructor, ensuring proper initialization of inherited properties. For example, a vehicle class can serve as a base, and a car class can extend it, inheriting shared behaviors while adding unique features. This approach enhances code organization and reusability. Encapsulation is a cornerstone of object-oriented design, and JavaScript now supports private fields using the hash symbol. By prefixing a field with hash, you restrict access to that property, ensuring it can only be modified within the class itself. This protects internal state from unintended changes, promoting safer and more predictable code. For instance, a car class might have a private field for speed, preventing external code from directly altering it. This level of control is vital for maintaining data integrity in complex applications. Polymorphism allows objects of different classes to be treated as objects of a common superclass, enabling flexible and dynamic behavior. In JavaScript, this is achieved through method overriding, where a child class provides a specific implementation of a method defined in its parent class. For example, a car class might have a drive method that behaves differently from a bicycle class's drive method. At runtime, the appropriate method is dynamically selected based on the object's actual type, allowing for versatile and extensible code structures. Static methods and properties belong to the class itself rather than instances of the class, making them accessible without creating an object. This is particularly useful for utility functions or shared data. For example, the math class in JavaScript includes static methods like max, which can be called directly without instantiating math. Similarly, a logger class might have a static log method for centralized logging. Static members are ideal for operations that do not depend on instance-specific data, improving efficiency and clarity. Advanced design patterns like the factory and singleton patterns are essential for solving common software design challenges. The factory pattern centralizes object creation logic, allowing for flexible and maintainable code when dealing with multiple object types. The singleton pattern ensures a class has only one instance, which is useful for managing global state, such as configuration settings or database connections. These patterns help create modular, scalable applications by reducing coupling and promoting reusability. JavaScript's inheritance model is based on prototypes rather than classes, offering a more flexible approach compared to classical inheritance. Every object has a prototype, which acts as a blueprint for its properties and methods. By using proto or object create, you can manually establish inheritance, allowing for dynamic and customizable object relationships. This prototype-based system provides greater flexibility, enabling features like mixins and dynamic property delegation, which are harder to achieve in classical models. Understanding this distinction is key to mastering JavaScript's unique object-oriented capabilities. In summary, this session has covered advanced object-oriented programming concepts in JavaScript, from E6 classes and inheritance to encapsulation, polymorphism, and design patterns. By leveraging these principles, you can create scalable, maintainable, and efficient code structures. Whether you're building complex applications or optimizing existing systems, a solid grasp of these concepts will empower you to design solutions that are both robust and adaptable. Keep exploring and applying these ideas to elevate your JavaScript expertise. Design patterns are like blueprints for solving common problems in software development. They provide proven solutions that developers can reuse to create efficient, organized, and maintainable code. In JavaScript, these patterns help structure applications in a way that makes them easier to scale, update, and collaborate on. By using design patterns, you can avoid reinventing the wheel and focus on building robust solutions. They are especially valuable in JavaScript because of the language's flexibility and dynamic nature, allowing for creative and efficient coding practices. JavaScript developers often rely on several key design patterns to manage complexity. The singleton pattern ensures a single instance of a class, which is useful for things like configuration settings or database connections. The factory pattern simplifies object creation by abstracting the logic for generating instances. The observer pattern enables event-driven architectures where objects can notify others of changes. The module pattern helps encapsulate code into self-contained units, promoting separation of concerns. Lastly, the prototype pattern allows objects to inherit properties and methods efficiently. Leveraging JavaScript's prototype-based inheritance, the singleton pattern is ideal for scenarios where a single instance of a class must be shared across an application. For example, a configuration object that holds global settings can be implemented as a singleton to ensure consistency. In JavaScript, this can be achieved using an object literal or a constructor with a private instance check. By restricting instantiation to a single object, the singleton pattern prevents unintended duplicates and centralizes access to shared resources. However, it should be used judiciously, as overuse can lead to tightly coupled code. The factory pattern is a powerful tool for simplifying object creation. Instead of directly instantiating classes, a factory function can determine the appropriate type based on input parameters. This is particularly useful when dealing with complex object hierarchies, or when the creation logic might change over time. For instance, a factory function could generate different types of vehicles based on user input, decoupling the client code from specific class implementations. This approach enhances flexibility and makes the code easier to maintain. The observer pattern is widely used in event-driven systems, such as user interfaces, where changes in one component need to trigger updates in others. It works by having a subject maintain a list of observers, which are notified whenever the subject's state changes. For example, a weather app might use this pattern to update multiple UI elements when new data arrives. The observer pattern promotes loose coupling between components, making the code more modular and easier to extend. Implementing it in JavaScript often involves creating a class with methods to add, remove, and notify observers. The module pattern is essential for organizing code into encapsulated units. By using an IIFE, developers can create private variables and functions that are not accessible from outside the module, while exposing only a public API. This helps prevent naming conflicts and keeps the global namespace clean. In modern JavaScript, E6 modules offer a more structured approach, allowing developers to import and export code across files. Whether using IIFEs or E6 modules, the module pattern is a cornerstone of scalable and maintainable applications. The prototype pattern leverages JavaScript's prototype-based inheritance to create objects by cloning existing ones. This is more memory efficient than using constructors, especially when creating multiple instances. For example, if you have a base object with shared methods, you can create new objects that inherit those properties without duplicating them. This pattern is particularly useful for scenarios where objects need to share functionality dynamically. Understanding prototypes is key to mastering JavaScript's object-oriented capabilities. The strategy pattern allows developers to swap algorithms at runtime, making it ideal for scenarios where different behaviors are needed. For instance, a payment system might use this pattern to switch between credit card, PayPal, or bank transfer methods. By encapsulating each algorithm in a separate object, the strategy pattern decouples the context from the specific implementation. This makes the code more flexible and easier to test, as new strategies can be added without modifying existing code. The decorator pattern is used to dynamically add behavior to objects without altering their structure. This is often achieved by wrapping an object with a decorator that enhances its functionality. For example, a logging decorator could be added to a function to track its execution time without changing the function itself. This pattern is particularly useful in scenarios where you want to extend an object's capabilities in a modular way, such as in middleware systems or UI components. While both the module and singleton patterns are valuable, they serve different purposes. Modules focus on encapsulation and organizing code into self-contained units, promoting separation of concerns. Singletons, on the other hand, ensure that only one instance of a class exists, making them suitable for global state management. Modules are ideal for structuring large applications, while singletons are useful for managing shared resources. Understanding when to use each helps avoid unnecessary complexity in your code base. Design patterns should be used thoughtfully, not as a one-size-fits-all solution. Overusing them can lead to unnecessary complexity and make code harder to read. Always prioritize clarity and maintainability, ensuring that patterns are applied where they genuinely improve the code. Modern JavaScript features like classes and modules provide cleaner alternatives to traditional patterns. So take advantage of these tools to write more concise and readable code. The goal is to solve problems efficiently, not to force patterns where they don't fit. Design patterns are invaluable tools for solving recurring challenges in JavaScript development. They enhance code quality, collaboration, and scalability when used appropriately. Choosing the right pattern for the right situation can make a significant difference in the long-term success of a project. As you gain experience, practice implementing these patterns in real-world scenarios to deepen your understanding and improve your problem-solving skills. Remember, the key is to balance pattern usage with simplicity and clarity. Performance optimization in JavaScript refers to the process of improving the speed, efficiency, and responsiveness of code to ensure it runs smoothly and consumes fewer resources. This is critical because inefficient code can lead to slow user experiences, unresponsive interfaces, and scalability issues as applications grow. For example, a website that takes too long to load or freezes during interactions can frustrate users and drive them away. Scalability becomes a challenge when the code isn't optimized to handle increasing data or user demands. The key areas we'll explore today include code efficiency, which focuses on writing clean and fast logic, memory management, which ensures the browser doesn't hold onto unnecessary data, and DOM handling, which optimizes interactions with the web page structure. These areas are foundational to building high-performing JavaScript applications. One of the most effective ways to enhance code efficiency is by minimizing redundant calculations. For instance, if a function recalculates the same value multiple times, it can slow down execution. Avoiding nested loops is another crucial step, as they can lead to exponential time complexity. Instead of writing manual loops, leveraging built-in methods like map or filter can improve readability and performance. as these functions are optimized at the engine level. Additionally, optimizing conditionals by structuring them to avoid unnecessary checks can reduce processing time. Function call overhead can also be significant, so reducing the number of nested or repeated calls can make a noticeable difference. For example, caching results of expensive operations or using memoization can prevent redundant work. These techniques collectively contribute to faster and more maintainable code. Memory management in JavaScript is essential to prevent memory leaks, which occur when the browser holds onto data that is no longer needed. Understanding how garbage collection works helps us write code that allows the engine to reclaim unused memory. For temporary data, using weak map or weak set is ideal because they don't prevent garbage collection of their keys, making them perfect for scenarios like storing private data or weak references. Another common pitfall is forgetting to remove event listeners or clear intervals and timeouts. For example, if a listener is attached to a DOM element that is later removed, it can still consume memory unless explicitly detached. Similarly, uncleaned timers can accumulate over time, leading to performance degradation. By proactively managing memory, we ensure the application remains efficient and avoids unexpected crashes or slowdowns. Optimizing DOM manipulation is crucial because the document object model is a critical part of web interactions. Reflows, which occur when the browser recalculates the layout of a page, can be expensive and cause jank. To reduce reflows, we can batch updates by making multiple changes to the DOM before applying them, such as using document create document fragment to collect elements and append them all at once. This approach minimizes the number of reflows. Additionally, accessing properties like offset height or client width repeatedly can trigger reflows. So it's better to store these values in variables if they're needed multiple times. For example, instead of checking the height of an element in a loop, calculate it once and reuse the value. These strategies help maintain smooth animations and responsive user interfaces. Asynchronous programming is a cornerstone of modern JavaScript, and using async await makes code cleaner and easier to manage compared to traditional callbacks or promises. This syntax allows developers to write non-blocking code that reads like synchronous logic, improving maintainability. However, event handlers for frequent actions like resizing or scrolling can cause performance issues if not handled properly. Techniques like debouncing and throttling limit how often a function is executed, ensuring the browser isn't overwhelmed. For example, a debounced search input only triggers a request after the user stops typing. For CPU-intensive tasks, web workers provide a way to offload work to background threads, preventing the main thread from becoming unresponsive. These practices ensure applications remain fast and user-friendly even under heavy loads. Profiling and debugging tools are indispensable for identifying performance bottlenecks. The Chrome DevTools Performance tab allows us to record and analyze the execution of our code, highlighting long tasks, network delays, or excessive garbage collection. By examining the timeline, we can pinpoint where the application is slowing down. Lighthouse, also part of DevTools, provides a comprehensive audit of performance, accessibility, and best practices, offering actionable insights to improve load times and user experience. The memory panel helps track memory usage, revealing leaks or inefficient allocations through heap snapshots. For instance, if an object isn't being garbage collected as expected, the memory panel can show its references. These tools empower developers to make data-driven decisions and continuously refine their code. To summarize, prioritizing efficient code, memory management, and optimized DOM practices is essential for building high-performing JavaScript applications. Regularly profiling and testing performance across different devices ensures that the application remains fast and reliable under various conditions. Staying updated with modern JavaScript features and tools, such as new language constructs or browser APIs, allows developers to leverage the latest advancements for better performance. By combining these strategies, we not only enhance user experience, but also future-proof our applications against growing demands. Remember, performance optimization is an ongoing process that requires attention to detail and a proactive approach to problem solving. Testing ensures code functions as expected by verifying that every part of the application works correctly under various conditions. This process helps catch errors early, saving time and resources in the long run. Debugging, on the other hand, is the systematic process of identifying and resolving issues in the code. It involves tracing the root cause of problems, whether they are logical errors, syntax issues, or unexpected behavior. Together, testing and debugging significantly enhance the reliability and maintainability of code. These skills are essential for professional JavaScript development because they ensure that applications are robust, scalable, and user-friendly. Without them, even the most well-designed code can fail in real-world scenarios. In JavaScript, there are several types of testing that serve different purposes. Unit testing focuses on testing individual functions, components, or modules in isolation. This helps ensure that each part of the code works as intended. Integration testing goes a step further by validating how different modules or systems interact with each other. This is crucial for identifying issues that arise from dependencies or data flow between components. End-to-end testing simulates real user workflows in a complete environment, ensuring that the entire application functions as expected from the user's perspective. Automated testing using tools like Jest, Mocha, or Cypress allows developers to run tests repeatedly and efficiently, reducing the need for manual intervention and ensuring consistency. When it comes to testing tools, JavaScript developers have several options. Jest is a popular choice for unit and integration tests due to its ease of use, built-in mocking capabilities, and fast execution. Mocha is highly flexible, especially for asynchronous testing, and allows developers to structure tests in a way that suits their workflow. Jasmine is a behavior-driven development framework that emphasizes writing tests in a natural, human-readable language, making it ideal for teams that prioritize collaboration and clarity. Cypress is specifically designed for end-to-end testing, offering real browser interaction and a powerful debugging experience. Each tool has its strengths, and the choice depends on the project's needs, team preferences, and the type of testing required. Debugging is an art that requires patience and a methodical approach. One of the simplest techniques is using console.log to print out values or track the flow of execution. This is great for quick checks, but can become cumbersome in complex applications. Setting breakpoints in browser developer tools allows you to pause the code at specific points and inspect variables, function calls, and the call stack. Adding the debugger statement in your code acts as a built-in breakpoint, pausing execution when the code reaches that line. During runtime, you can also inspect variables, step through code line by line and analyze the call stack to understand how the code is behaving. These techniques help pinpoint issues that might be difficult to spot otherwise. To write effective tests, it's important to follow best practices. One of the most powerful approaches is test-driven development, where you write tests before writing the actual code. This ensures that your code meets the required specifications from the start. Keeping tests isolated and repeatable means each test should run independently and produce the same results every time, avoiding dependencies that can cause unpredictable outcomes. Using mock functions to simulate external dependencies, such as APIs or databases, makes tests faster and more reliable. Finally, maintaining a consistent testing framework across the team ensures that everyone follows the same standards, making the code base easier to maintain and collaborate on. Effective debugging starts with reproducing the issue consistently. If you can't reproduce a problem, it's difficult to fix it. Browser developer tools are invaluable here, with the Network tab for checking API requests, the console for viewing errors, and the Sources tab for stepping through code. It's also important to avoid minifying code during debugging, as minified code is hard to read and trace. Instead, use source maps, which map the minified code back to the original source, making it easier to debug transpiled code. These practices help you quickly identify and resolve issues without getting lost in complex, obfuscated code. Code coverage measures how much of your code is tested, helping identify untested sections that might contain bugs. Tools like Istanbul or coverage reporters integrated into testing frameworks can generate detailed reports. While aiming for high coverage is good, it's more important to focus on critical paths and high-risk areas of the application. For example, a function that handles user authentication should have thorough tests, even if other parts of the code have lower coverage. Integrating coverage checks into your CI/CD pipeline ensures that tests meet predefined thresholds, preventing untested code from being deployed. This practice promotes accountability and continuous improvement. Avoiding common pitfalls is key to effective testing. Overlooking edge cases, such as empty inputs or unexpected data types, can lead to bugs that only appear in real-world scenarios. Relying relying solely on manual testing is inefficient and error-prone, as it's easy to miss subtle issues. Ignoring test failures or skipping tests can create a false sense of security, leading to undetected problems. Finally, not updating tests when code changes can result in outdated tests that no longer reflect the actual behavior of the application. These pitfalls can be mitigated by fostering a culture of thoroughness and continuous testing. Continuous integration, or CI, automates testing by running tests whenever code is committed to a repository. Platforms like GitHub Actions or Jenkins allow developers to set up workflows that trigger tests on every pull request or commit. This ensures that any changes are immediately validated, reducing the risk of introducing errors. If tests fail or coverage thresholds aren't met, the build can be marked as failed, preventing problematic code from being merged. This practice provides faster feedback, enables early detection of issues, and fosters a more reliable development process. CI is a cornerstone of modern software development, ensuring that code is always in a deployable state. Testing and debugging are critical for building reliable JavaScript applications. By using the right tools, such as Jest, Mocha, or Cypress, and following best practices like test-driven development and consistent frameworks, developers can ensure their code is robust and maintainable. Automation, high code coverage, and integration into CI/CD pipelines further enhance the efficiency and reliability of the development process. Mastering these skills not only improves the quality of the code, but also builds confidence in the application's performance. As JavaScript continues to evolve, these practices remain essential for creating scalable, user-friendly, and error-free applications. Good afternoon, everyone. Today, we will dive into the final project that will serve as the culmination of our 30-session journey through JavaScript. The primary objective of this project is to apply the concepts we've learned in a practical, real-world context. By doing so, you'll not only solidify your understanding, but also develop a portfolio-worthy application. The project scope includes building a functional web application, which could range from a task manager to a data-driven dashboard. Deliverables will consist of the source code, a documentation file, and a short presentation to showcase your work. This is your chance to demonstrate your skills and creativity. Let's discuss the requirements for the final project. First, we have functional requirements, which define what the application must do, such as user authentication or data retrieval. Non-functional requirements focus on performance, scalability, and usability. Mandatory features will form the core of your project, while optional enhancements allow for creativity and advanced implementation. For example, you might choose to add animations or integrate third-party APIs. The deadline is set for the end of this month, and submissions must follow the specified format, including a GitHub repository and a README file. Make sure to review the guidelines carefully to avoid any last-minute issues. Now, let's break down the development process. The first step is planning and designing your project structure. This involves defining the architecture, choosing libraries or frameworks, and outlining the user interface. Next, writing and testing code incrementally ensures that you build a robust application. For instance, start by creating the basic structure, then add features one at a time, testing each part as you go. Finally, debugging and optimizing performance are critical. Use tools like the browser's developer console, unit tests, and profiling tools to identify and fix issues. Optimization might involve reducing load times or improving memory management. Remember, this phase is where your problem-solving skills will shine. It's time to present your final project. During the demo, I'll walk you through the key features of your application, highlighting how they meet the project's goals. For example, if your app includes a search function, I'll demonstrate its efficiency and user-friendly design. I'll also discuss the challenges you faced during development, such as debugging a complex algorithm or integrating a new API. These challenges are part of the learning process, and sharing them will help others understand the problem-solving journey. Be prepared to answer questions about your design choices and implementation details. Let's take a moment to recap the 30 sessions we've completed. We started with the basics of JavaScript syntax, including variables, data types, and control structures. As the course progressed, we explored DOM manipulation, allowing you to dynamically update web pages. Later, we delved into APIs, learning how to fetch and display external data. The journey has taken us from writing simple scripts to building interactive applications. This course has been a stepping stone from foundational knowledge to mastering advanced concepts like asynchronous programming and modular code. Today, we'll revisit the key concepts that form the backbone of JavaScript. Variables and functions are the building blocks of any program, while control structures like loops and conditionals enable decision-making. Object-oriented programming allows you to create reusable and organized code through classes and inheritance. Ease 6 introduced modern features such as arrow functions, destructuring, and modules, which streamline development. Asynchronous programming using promises and async await is essential for handling tasks like API calls. Finally, error handling ensures your applications are resilient and user-friendly. These concepts are the foundation of any JavaScript developer's toolkit. Let's address common mistakes that even experienced developers encounter. Syntax errors, such as missing semicolons or incorrect brackets, can be frustrating, but are usually easy to fix with a linter. Scope and closure pitfalls often arise when variables are accessed outside their intended context, leading to unexpected behavior. Inefficient code, like using nested loops unnecessarily, can slow down performance. To avoid these issues, always test your code thoroughly. Use tools like EaseLint and follow best practices such as writing modular code and optimizing algorithms. These habits will save time and improve the quality of your work. As we wrap up, let's discuss what comes next. I recommend exploring additional resources like online tutorials, books, or community forums to deepen your knowledge. Building personal projects and portfolios is a great way to apply what you've learned and showcase your skills to potential employers. Additionally, consider exploring frameworks like React or Node.js to expand your expertise. Real-world applications will challenge you to think critically and adapt your skills to new scenarios. The path to mastery is ongoing, and these steps will help you continue growing as a developer. Now it's your turn to ask questions. Whether you need clarification on the project requirements, want to discuss coding challenges, or seek advice on your next steps, I'm here to help. Feel free to share your thoughts and collaborate with your peers. Peer feedback is invaluable as it offers new perspectives and helps identify areas for improvement. Don't hesitate to engage in discussions. Your insights and questions are important. Let's make this session interactive and beneficial for everyone. To conclude, I want to acknowledge the progress you've made throughout this course. From writing your first lines of JavaScript to building complex applications, you've come a long way. Keep practicing, experimenting, and pushing your limits. The skills you've gained will serve you well in your coding journey. Thank you for your dedication and hard work. I'm confident that you'll continue to achieve great things. Stay curious, stay motivated, and keep coding. And just like that, our dreamy coding adventure has come to an end. I hope the gentle ebb and flow of the tutorial, combined with the tranquil melodies, have left you feeling both informed and at ease. Whether you managed to catch every line of code or drifted off into a peaceful slumber, remember that the world of JavaScript will always be here waiting for you. Keep your code clean, your mind open, and your spirit relaxed. Don't forget to subscribe to Code Snooze so you never miss out on another soothing coding journey. Hit that like button if this video brought you a moment of calm and learning, and share it with fellow coders or anyone in need of a serene study session. Thank you for joining me in this cozy corner of the internet. Until next time, may your code run smoothly and your dreams be filled with brilliant algorithms. Sweet dreams, sleepy coders.